Assume two metal plates attached to each other by a rivet. If I apply a force P on each plate in opposite direction, there will be some stresses generated at cross section of the rivet, and if the rivet is unable to withstand that force, it will break along the cross section. So in this arrangement, force P is the shearing force and the stresses it produces in the cross section area is the shear stress. So shear stress in this arrangement will be force resisted by rivet PR divided by cross-sectional area of rivet A. Shear stresses is generally denoted by Greek letter tau. Unit of shear force is Newton or pound force, and unit of shear stress is pound force per area or Newton per mm square or pound force per inch square. Now let's see some real life examples where we can use shear force. First comes cutting of paper by scissors, or cutting a cake by a knife, or punching holes in a paper by a paper punching machine, or cutting nails by a nail cutter. All these actions make use of shear forces. Now let's see where shear forces are generated in civil structures. Let's assume construction site which has soft soil for the foundation. For this site, pile foundation is used for building. Assume a single pile for representation purposes only. The load from the structure will be passed to the ground via friction piles. Friction or shear forces between soil and pile foundations keeps the building standing still, and if the length of the pile is not sufficient enough to resist the building forces, then foundation will fail. Now let's assume a concrete floor slab in a building supporting on a column load with load W. The column will punch into the slab if slab and the reinforcement in it are not able to resist the shear stresses. Similar thing will happen in an isolated footing resisting the soil reactions from the bottom if it is inadequate to resist the shear forces. These two examples of failure modes in slab and footing are called two-way punching shear failures. Now let's see how shear forces are acting on a retaining wall. The retained soil behind the shear wall will try to slide the wall along it. The frictional force generated between the wall bottom and ground below will resist it, hence saving it from sliding. But if the length of the wall footing is not enough, the wall will fail in sliding. Now let's see how shear forces vary along a concrete beam loaded with uniform load W supported on points A and B. If we write the equilibrium equations along vertical direction, we will get the support reactions VA and VB as WL by 2. If we want force at center of the beam C, by assuming half of the beam, we get zero reaction at the point C, as VA will cancel out WL by 2. By this information, we can draw a shear force diagram with VA and VB at extremes and zero force at center. Now you will wonder how positive and negative signs are assigned on this diagram. So if a section has upward force on left and downward force on the right, it is denoted by a positive sign. And if a section has downward force on the left and upward force on the right, it is denoted by a negative sign. Now let's see what kind of cracks are produced in a concrete beam due to flexure and shearing stresses. Let's assume a concrete beam loaded with line load W. There are basically three kinds of cracks produced in a concrete, which are flexural cracks or cracks due to bending of the beam, flexural plus shear cracks which are caused due to combination of bending and shear forces, and lastly shear cracks which tend to come up near the support due to shear forces. To arrest these cracks, reinforcement is provided in the beam. The longitudinal reinforcement, also called as flexural reinforcement, prevents the bending of the beam and hence arrests the cracks due to flexure and flexure plus shear. The shear reinforcement in the form of stirrups is provided to make the beam stronger in shear and prevent the shear cracks. Note that shear stirrups are closely spaced near the supports as shear is higher near the supports. Going back to our floor slabs and column illustrations, the two-way punching shear failure can be avoided either by providing stirrup reinforcement or shear strips or by increasing the depth of the slab under the column, also called as column drop. Similarly, the two-way punching shear failure in an isolated footing can be avoided by providing shear reinforcement or increasing the depth of the footing. That's all for this video, guys. Hope you enjoyed the learning about shear forces.